Hi everyone, if you've been wondering what is all this Kubernetes fuss all about, then this is the video for you. I'm going to introduce Kubernetes and I'm gonna show you a demo that you can easily follow along. So stay tuned. So let's dive right into Kubernetes, aka K8s, the shorthand that people use when they refer to Kubernetes. What is Kubernetes? The question on everybody's mind is basically a platform for running containers similar to Docker Compose, Docker Swarm, except on steroids, basically. So it takes care of starting your containerized applications, rolling out updates. Basically, when you deploy a new version of a service which is already deployed, it basically starts the new version as well, having at the same time two versions, and then switches quickly the pointer to the new version and then takes care of taking down the old version. So essentially deploying updates with minimal downtime, maintaining service layers, taking care of how your services are exposed to the world, basically scaling to meet the demand, auto scaling, manual scaling, all sorts of scaling options are available for the developers or infrastructure engineers, etc. And things such as security, access, and many more benefits. So why use Kubernetes? Well, one of the main reasons is to have independence from cloud providers. Once you have your app nicely running in Kubernetes, you can essentially deploy it on any cloud of your choice. And as well as after you have deployed it in a cloud, if you're not satisfied with that cloud, maybe it raised the price, you're not as satisfied with that, maybe it lowered its availability and you're not satisfied with that, you can migrate to another cloud provider. Just take given that your whole application architecture works on top of Kubernetes, you take the entire thing and deploy it in another cloud provider. However, I have to say that from experience, maintaining Kubernetes infrastructure is quite challenging. So it is recommended to use a cloud provider or to use a managed offering of Kubernetes from a cloud provider. But given the fact that most of the cloud providers nowadays offer managed Kubernetes, that is quite nice. So we have the managed Kubernetes offering from Google, the original developer of Kubernetes, and managed offerings from AWS, Microsoft, and so on. So to continue, it enables organizations to move between data centers and other clouds without a rewrite. Parenthesis here, minimal degree of rewriting. And there are technologies such as Terraform, which help you achieve that minimal degree of rewrite through solutions such as infrastructure as code. And the last reason why Kubernetes, because everybody's using it, it's cool, and if you want to feel like a true Chad, you better use Kubernetes. So let's see what all this Kubernetes is all about in practice. Well, not yet. Many people consider Kubernetes quite hard, and I think they have their reasons, because Kubernetes, even simple apps in Kubernetes are deployed in multiple components in it. It has a custom file format that can easily span at least dozens of lines and even can grow up to hundreds of lines. It brings infrastructure level concerns such as load balancing, networking, storage, and compute into that configuration. It combines many concepts that require, of course, quite a versatile IT background, and it's always expanding. Not that it's a bad thing, but releases come out every quarter and it can be quite hard to catch up with all the new functionality that is coming out. So when to use Kubernetes? Well, I would say if you're beginning a project or even a project, such as you're beginning your startup, you have a vision for it, but until you've reached Series A, I would recommend that you just go bare metal, just get a server from DigitalOcean, or just a simple server from your cloud provider of your choice, instead of basically having to deal with all of this Kubernetes basically challenging aspects that I've previously mentioned. So until Series A, maybe nay. Series A, once you've raised, you got some capital, maybe you could consider Kubernetes if you got already some experience with it in the past. But still, I would think it will be quite time consuming. And if you've already reached, let's say, Series B, you've got considerable capital, or maybe you're an expert in Kubernetes, then you can do it, and you definitely see yourself needing Kubernetes in the future, then go for it. Or you've reached Series B and basically you have nowhere to throw your money, you hire a Kubernetes expert and you pay them to handle all your Kubernetes for your application. Why do I present all this? Well, maybe so that you can brag to all of your friends that you know Kubernetes. Maybe you get hired by all of these tech companies, and surely they got some Kubernetes related bugs in their issue tracker for you ready to tackle. Or maybe just in case, so you know it, who knows. So next up, what can we do for a little demo? Well, I would say that we still need to familiarize ourselves with two key concepts here regarding Kubernetes. The Kubernetes API and the Kubernetes cluster. So let's start with the Kubernetes cluster. The cluster essentially runs the applications. It's comprised of a bunch of servers called nodes that have a container runtime, most often Docker, and using the Kubernetes software, they are basically joined onto a single logical unit called the Kubernetes. And basically, in your day-to-day life as a developer, you kind of treat Kubernetes as a single entity, even though it's a cluster of many servers and nodes. You just deploy your application onto Kubernetes, you pass it onto Kubernetes, and Kubernetes itself is going to calculate how many resources does it have, and it's going to deploy your application onto a node or many nodes, depending on how you've configured your application. So it's going to take your application, take a look at what's existing, what is the resource pool, what are the requirements of your application, and it's going to run that or return you an error that it cannot run that. So as we see here on the figure, we have the icon of presumably a person with a raised hand and a stick. So that is a contain. It reiterates to us that Kubernetes is a container orchestrator, and a cluster again is comprised of many server nodes, and server nodes run the Kubernetes API, which lets us control Kubernetes. I will talk about that in a bit more detail a bit later. So some servers and nodes run the Kubernetes API, which allows us to control Kubernetes, and other nodes/servers, they run workloads, applications in containers, essentially. And down below we have here mentioned that we can select from a bunch of container runtimes, such as Docker, Containerd, and RKT, whatever those last two are. And Kubernetes allows us to combine sort of Linux and Windows nodes. I will not go too much into that. So let's continue regarding the administration of the cluster. So-called this cluster administrator role can be a dedicated infrastructure engineer, or can be the same person or developer, depending the size of your team. So even though I mentioned that in your day-to-day life as a developer, you don't really care about the intricate details of the infrastructure, of Kubernetes. If you happen to be at the same time the cluster administrator and the developer, you kind of need to know all this. So cluster administrator manage individual servers called nodes in Kubernetes, and the functionality which is available to you as a cluster administrator is to add nodes, to expand the capacity of your cluster, remove nodes, roll out upgrades of Kubernetes software, and etc. etc. In managed services and offerings from various cloud providers, it's quite easy to manage your Kubernetes cluster. Essentially, you just have to click some buttons. And that is basically it in terms of the cluster. Instead, in terms of the Kubernetes API, it's basically YAML. So you control your cluster and you also deploy applications via YAML and via a REST API which Kubernetes offers to you, and it requires from you YAML in the HTTP body of your requests. So to deploy some applications to Kubernetes, you define your apps in YAML files and basically send that YAML to Kubernetes using the Kubernetes REST API or the Kubernetes command line tools. You can use that as well. So what Kubernetes it will do is, once it receives that YAML, it will look at what you've defined in there. It compares to what is the resource pool available, what services are already running, and it basically executes a delta between what it has and your new state, and basically results in a new state. Okay, so if it has 0 applications running, you're sending a new YAML which says I want to deploy a new application, then the result is a new application. If the existing state is, let's say your application is running and you're sending another YAML which is meaning that I want to start the application, then it takes down the existing application version and deploys a new version of your application. Or you're sending a YAML that you want to scale, then it gives you 2 instances of your application and things like that. Containers are distributed around the cluster, okay, for high availability, and they can all communicate over virtual networks managed by Kubernetes, essentially meaning that you just send it a YAML that I want to start an application, and Kubernetes itself is going to decide on which node and on which server your containers are going to be started. Okay, and once you start various application and combinations of applications and databases in your Kubernetes cluster, it gives you a shared network so that all of your applications can communicate between each other, basically. And the figure that we see on the right basically shows the deployment process without abstracting the nodes and servers, because we don't care about them already at this level. So we see here, that somebody types in some YAML and it sends it to the Kubernetes API, and Kubernetes basically deploys it somewhere in a container. Okay, and these arrows in here basically mean that this container can communicate to the other container via all these dotted lines, which means the shared network that Kubernetes provides. And we see here that there are 2 of these containers placed next to each other, meaning that that is, let's say, 2 instances, so it's like a scaled up version of an application. But Kubernetes is more than containers. It can store configurations and secrets like API keys and connection credentials. It can also offer you a way of providing storage to your applications, whether it's storage that is available on disk of the servers themselves and / the nodes, or it's some kind of network attached storage. It gives you a sort of a managed network so that you can create this communication between your applications and much more than that. So what about the containers themselves? Well, Kubernetes doesn't really care what runs and executes inside them. You can run an application comprised of a dozen of microservices running in multiple containers. You can run one legacy application, essentially a monolith, which takes as many resources as Kubernetes has to offer. They can be Linux apps, Windows apps. Basically, you just define your applications in YAML files, and you can run them on a single cluster. That's basically the joy of working with Kubernetes, is that no matter what your application is written in, as long as it's Dockerized and you've defined all of these YAML configuration files, they are basically deployed, scaled, and managed by Kubernetes in the same way, no matter what the implementation is, whether your microservice architecture comprise of .NET, Java monoliths, and Node and Go microservices. They will all be managed in the same way by Kubernetes. So, sounds easy? Well, why don't we take a look at some more specific definitions before proceeding to our demo. So, let's look at some specific definitions. I've mentioned many times YAML files, which are essentially called application manifests, and using inside of these application manifests, you can create all kinds of combination of complex deployments. And here on the right, we have a representation of such deployment, which was defined using YAML, but is represented visually in here using the exact Kubernetes definitions. So we have here the concept of a service, which exposes our application to the outside world, in here port 80. We have the concept of a pod, which is essentially can be one or many containers. In here we just see one container. The pods themselves can be replicated and grouped into so-called a replica set, okay, which is exposed, again, connected to the service to be exposed to the world. The whole thing is grouped into an element called a deployment. To the pods, we have here connected a config map, which essentially stores configuration, as mentioned before, like environmental variables and whatever configuration that your application needs. Then on the right from this deployment, we got an other deployment, again a single pod, which is a group of containers which contains just one container. In here, a replica set which contains of just a single replica of this pod. It's wrapped in this deployment, and attached to it we have some storage referred to as a volume, and some let's say secrets, some passwords which are referred to as application secrets. And we have this arrow in here in the sense that this particular pod wants to communicate to the deployment on the right, and it does it via accessing the deployment's service. That's how it basically gets access to furthermore to the pod and the application in here by using the service that is exposed. So finally, demo time. I'm going to follow a tutorial which is located at scaffold.dev/docs/quickstart. In this tutorial, we're using a bunch of tools, which I'm going to mention to you. First of all, we're using this light version of Kubernetes, which is called Minikube. We're using the command line interface to Kubernetes called kubectl, and we're using a tool called Scaffold, which is where we get the tutorial from. Essentially, it's a Scaffold tutorial, which is a tool. You can think of it as like Docker Compose, but for Kubernetes. So Docker Compose, basically what it does is allows you to write this configuration instead of running multiple Docker run command line statements. So what Scaffold does is the same thing, allows you to write a scaffold configuration so that you don't have to write all of these kubectl commands. So let's get into it. So you have two options here basically. Either you install all of these three tools, Minikube, kubectl, and Scaffold, but I wouldn't recommend that. Or you can use the Google Cloud Shell available from Google Cloud if you have a Google account. So this is what I'm going to do for this demo. So I'm going to proceed by opening Google Cloud Shell. I'm going to confirm everything. I'm giving up my apartment, my car, everything here. Let's wait a little until we are provisioned all of the resources. Google is downloading all of my personal data at the moment, which is fine, and it finished successfully. So let's follow the tutorial in here, which I actually lost. So I'm going to go again and open it. So what we have to do is basically get some sample code to be able to run. So we have to clone basically this repo. That's what I'm gonna do. So after we clone, we cd into the basically examples folder and getting started. Then we can execute ls to see what we have inside of this getting started folder. And what we got in here is basically a Golang application. We can take a look at that Go application and see what it does. I'm using the cat and cat main.go. So it's a simple app which basically prints hello world, sleeps for 1 second, and then again it's basically an infinite for loop that prints hello world at a 1 second interval. Then we have the Docker file for dockerizing this application. We can take a look at that as well. Essentially, we're building here a Golang container in 2 stages. First stage uses the main sort of heavy image of Golang. It builds an executable, and then in the second basically stage here, the executable is copied from the first builder stage into the second stage. And when we run, we basically execute the app executable. As simple as that. So then we can explore the Kubernetes parts, which allow us to let's say configure the deployment of this particular application onto a Kubernetes cluster. And in our case, we're going to use Minikube, but the same YAML can be used as well for deployments in an actual Kubernetes cluster. At least for this very simple example, it should be the same. For maybe more complex examples, of course, there will be differences between this Minikube Lite version of Kubernetes and the actual Kubernetes cluster. So let's take a look at this Kubernetes pod YAML in here. So it's a simple pod, as we can see from the name of the YAML in here. And if you remember from the presentation, that essentially this pod is the simplest version. In here we can overcomplicate it as well using replica sets and deployments and so on, but the pod is the simplest version of essentially deploying something, an application to Kubernetes, and it's essentially a group of containers, one container or multiple containers. In our case, it's going to be just a simple single Docker container for this Golang application. So let's take a look at what we got in the YAML. So we got the API version of Kubernetes. We got some, let's say, kind attribute. I'm not going to go really in depth onto the YAML specification of Kubernetes, but I guess it's pretty intuitive here that we got the API version of Kubernetes. It's basically the string of the version and the kind, what we're deploying a pod in here. We got some metadata with the name, how we're going to be referencing to it later on when it's deployed, and spec, shorthand from specification, that we're deploying a bunch of containers. And here we could have added multiple containers, but we just have one container with the name getting started, and the image is going to be the scaffold example in here. And let's take a look at what our scaffold configuration looks like, which is the tool. Again, I'm reiterating, it's like Docker Compose for Docker, but it's for Kubernetes. So essentially, it allows us to write the specification to, instead of writing many kubectl command line, basically commands. So let's take a look at what we got in the scaffold. I will do cat scaffold. And using the scaffold, we're basically saying that we want to deploy basically all of the application manifests in the current folder that start with the name K8s. And this is going to eventually, of course, pick up our file, which is called K8s pod YAML. And basically, it also is going to, before deploying via kubectl all the YAML files that start with K8s, is going to build. We can't tell really from here but it's going to build using Docker. It's going to take the Docker files, the Docker file in the current folder, and it's going to build a single artifact with the image name scaffold example. Okay, and therefore in our Kubernetes pod YAML, we of course will have access to that image called scaffold example, because it will be generated by the build stage of scaffold. Okay, so having explained all that, why don't we proceed to see everything in action? And the commands that you need to follow for the demo are the following. There is one missing command in here, which is we actually have to start Minikube, and I will actually edit in here like so. It's actually missing from this quick start as well. Without it, I wasn't able to make it work. So let's start Minikube and give it some time. It will ask us for credentials to make a Google Cloud Platform API call. I think that is fine. So Minikube start command has finished successfully, meaning that we have a running Minikube, and we can proceed executing scaffold run to basically kick off the deployment process, which will deploy and use our Kubernetes pod application manifest to perform the deployment of the particular Golang application to our Minikube cluster. However, I've encountered a small issue which I managed to resolve, and the issue is that Scaffold has released a new version basically a couple of hours ago, and it was updated in the GitHub repository. So this particular example, getting started of Scaffold, was assumes the version 1.22. However, in this particular Cloud Shell, we have the Scaffold version 1.21. So to fix that, we basically will need to update the Scaffold. So if you have that issue, what you'll need to do is, instead of requiring the version 2 beta 14, is you'll need to require the version 2 beta 13, which is the 1.21 version of Scaffold, which we currently have on this Google Cloud Shell instance. So I'm quickly going to do Control O and I'm going to hit Enter and then Control X to save everything, and then I'm ready to do Scaffold run. So at this point we can consider the deployment successful. So what we have to do is basically use the kubectl command line Kubernetes tool in order to inspect our deployment and make sure that everything was deployed successfully. We've got our pod, and we can inspect the logs and see that hello world message being printed. So in order to do that, we can use the kubectl get pods to list our deployed pods. We can see here we have the getting started pod, and we can also get the logs via the kubectl logs and the name of our pod. So it's going to be kubectl logs getting started, and we see that loop of hello world messages. So that was it. Thank you for your attention, and see you in the next tutorials. Take care. Ciao, ciao.